Back to another video lesson. This lesson is going to cover how to find the areas of trapezoids, rhombuses, and kites. Okay, so if you want to pause the video, just copy up to this section here, and then you may press play. Alright, so to find the area of a trapezoid, we need to have the height and the two bases. Okay, so this is base 1, base 2. And this is the formula to find the area of a trapezoid. So 1/2 the sum of base 1 and base 2 multiplied by the height. For a rhombus and a kite, if we know diagonals, if we know the two diagonals, all we have to do is we take 1/2 and then multiply diagonal 1 times diagonal 2. So if you multiply these two and you take 1/2 of that product, that's going to give you the area of that kite or rhombus. Okay, so on the next problem here, and I don't know if you guys have ever looked at the map of Nevada. So this is what it looks like. It has kind of a shape of a trapezoid. It's not perfect, but it's close. Okay, so as you can see, this is a trapezoid. So to find the area of this trapezoid, we're gonna use this formula here. So the formula is the area equals 1/2 the sum of base 1 and base 2, and we multiply that by the height. So as you can see, we need to be able to distinguish which are the bases and which is the height. So this side and this side are parallel to each other, which means these are the bases. So and the height is always perpendicular to the base, so that means this is the height here. So I'm going to substitute the values into this formula. So 1/2, and it doesn't matter which is base 1 and which is base 2. So 205 plus 511, the height is 309. Okay, and again, when you enter all of this in your calculator, is going to give you that the area is equal to 110,622 miles squared. Okay, so there is the area of this trapezoid. On this next example, we have another trapezoid. Again, we need to notice that this side is parallel to this side, which means these two are the bases. Okay, but there's something else we don't know here. We don't know the height. Okay, so we need to find the height. And this is something that we learned before this long break that we had. So if this is a right triangle, then this angle here has to be 30 degrees. Why? Because this is a 30, 60, 90 right triangle. Since this angle is 90 and this one is 60, if you add those two angles, they add up to 150, right? Which means that, well, since we know that all the angles in a triangle have to add up to 180, these two add up to 150. So subtract 150 from 180, and what's left is going to be the measure of this angle here. So this angle has to be 30 degrees. Also notice that this side is 5 and this whole side is 7, which means that this segment here is 7 minus 5. So that tells you that this segment is 2. Now, also remember, the short leg is always opposite to the 30-degree angle, okay? And the hypotenuse opposite to the right angle. So I don't know if you guys remember the pattern, but the pattern looks something like this. So if you have a 30, 60, 90 special right triangle, this is the short leg, this is the long leg, okay, and this is the hypotenuse, 2 times x. So in this case, x equals 2. So that's one opposite to the 30-degree angle, which means that this one has to be 2 square root of 3. So there is a height. So now we have the basis and the height of this trapezoid, so we can go ahead and find the area. So the area is going to be equal to 1/2, again, base 1 plus base 2 times the height. Okay, so this is 1/2 Base 1, let's say it's 7, and base 2 is 5, and then the height is 2 square root of 3. Okay, so this is going to be equal to 1 half times 12 times square root of 3. But half of 12 is 6. So this equals 6 times 2 square root of 3. And then we multiply 6 times 2. And in the end, we find that the area is equal to 12 square root of 3. And let's leave it like this for now. Okay, so we'll say meters square. So that is the exact area of this trapezoid. Okay, on these last two examples, one is going to be for a kite and the other one will be for a rhombus. Okay, so for a kite, don't forget that this diagonal always bisects the shortest diagonal. So since this segment is 3, then this one is to be 3. Okay, so diagonal 1, let's say it's this one here, that's going to be equal to 7, and diagonal 2 is going to be the sum of these two segments here, so that's going to be equal to 6. To find the area of a kite or a rhombus, we take 1 half, okay, of diagonal 1 and diagonal 2, the product of diagonal 1 diagonal 2. So then this area is equal to 1 half. Diagonal 1 is 7 and diagonal 2 is 6. So 7 times 6, which is 42, but half of 42 is equal to 21. And in this case, I'm just going to say units square. Okay, they could be meters, inches, kilometers. It doesn't matter which units are, but they have to be squared. So let's go to the next problem, which is a rhombus. Okay, now this one here, again, they just give us this side and this segment here. Okay, but on a rhombus, don't forget that this one is equal to this one here, and these two are also equal. And when the diagonals intersect, they form a right angle because they are perpendicular. That always happens in a rhombus, and it's two of the properties of a rhombus. So if this is 2.5, then this is also 2.5 feet. Okay. So now we just need to find this leg because this is a right triangle. So for this, we can use Pythagorean theorem. So if you use Pythagorean theorem, and I'm going to do this on the side, so it's a squared plus b squared equals c squared. So we know the hypotenuse, which is 6.5. So this is 6.5 squared, and this will be, let's say we don't know a. Okay, so a squared plus 2.5 squared. So if you enter this in your calculator, this will give you 6.25 units. Okay, and then if you take the square of 6.5, that is going to give you 42.25. If you subtract this from both sides, okay, so subtract 6.25, then we're left with a squared equals 36. And then last, we take the square root of both sides of the equation, and for geometry, this is equal to 6. Okay, so this is 6 and this is 6. So now, as you can see, we have this diagonal and this diagonal. So let's say diagonal 1 equals 6 plus 6, so that's going to be 12. Diagonal 2 is going to be equal to 2.5 plus 2.5, that's equal to 5. Okay, so then to find the area, that's equal to 1 half 12, the product of 12 and 5. 12 times 5 is 60, and half of 60 is 30. Okay, so it has to be 30 feet square. So there is the area of this rhombus. I'll see you guys on the next video lesson. Bye bye.